Hello, this video is for Learning Intention 35 and we're going to find the area under a curve, and I'm going to give you an example. So these are very popular exam style questions and they love using ridiculous language to make it sound convoluted and tricky and try to trip you up. So I'm going to make up a question that's kind of straightforward, but I'm going to make it sound as complicated as I can. So the question might look something like this. It might say, find the area bound, I love the word bound, by the curve f of x equals e to the power of x on 2 plus 1. The line x equals 1 and the line x equals 4 and the x-axis. Find the area bound by the curve f of x equals e to the power of x on 2 plus 1, the line x equals 1 and the line x equals 4, and the x-axis. What's it talking about? Well, you want to sketch stuff here. You want to do a sketch to find out what it's talking about, and then what it's talking about should become far more obvious and you realize you're worrying about absolutely nothing. So let's just sketch the curve. It's an exponential function, so do your DRT, do all that sort of stuff to make sure you can sketch the curve. I'm not going to do it, I'm going to do it in my head because I know that, well, it's e to the x on 2, so there's a dilation factor, and the asymptote's up here, so it's plus 1. So we know that y equals 1, there's our asymptote. The y-intercept is when x equals 0, so the y-intercept is at 2. So let's say it's there, and your curve's going to look something like that. Cool. So this value there is 0, 2. There's our curve. Find the area bound by the curve, the line x equals 1. Well, the line x equals 1 looks something like this. There's the line x equals 1. And then the line x equals 4. So 2, 3, 4. The line x equals 4. So that's x equals 1. That's x equals 4. And the x-axis. So it wants us to find this area. That's what it's asking. It's saying integrate from there to there to find this area. But you've got to watch out for this language. Let's find the area. So it's the integral from 4 to 1, so there are our terminals of the curve shown here. That's what this is asking you. That is that. Find the area bound by the curve, blah blah blah, and the x-axis. That's what that is. You've just taken all those words and put it into that. So let's integrate. So we divide by half, which is same as timesing by 2. Integrated there. Let's sub in our values. So that's 2e squared plus 4 minus 2e to the power of a half plus 1. What can we do here? Well, we haven't got like terms, so it's 2e squared minus 2e to the power of a half plus 3. 4 minus 1 is 3. That's your answer. And because it's asking for the area, we like to write units squared to show we know what we're doing and we know it's an area. You might see factorized. I don't know, they might want to be a bit fancy. They might take out the 2. They might put it as a square root of e plus 3. They're the same thing, but the game's the same. That's the answer. and that's the area under this curve, which is pretty cool. You can find the area under a curve by integrating. So I just wanted to leave you with that example for finding the area under a curve, and if you have been, thanks for watching.